simple pendulum, simple pendulum, okay, a simple pendulum. A simple pendulum is a heavy particle. A simple pendulum is a heavy particle. Heavy particle. A simple pendulum is a heavy particle, ideally point mass. Ideally point mass. Okay, point mass. Okay, suspended by an inextensible extensible and weightless string from a rigid support, from a rigid support. Okay, a simple pendulum is a heavy particle, ideally point mass. Okay, a simple pendulum is a heavy particle suspended by an inextensible and weightless string from a rigid body. Okay, let S be the point of suspended, and O mean our equilibrium position of the pendulum is that bob. Okay, bob. Suppose the bob is displaced through an angle theta. Suppose the mean and equilibrium position of the pendulum, and suppose the bob is displaced. Displaced through an angle theta. Then the weight mg, acting downwards exerts a torque minus mgl sin theta, about the point of suspended, tending to bring it back to O. The minus sign indicates that the torque is oppositely directed to displacement theta. Okay, torque equal to minus mgl sin theta. Torque equal to force multiply displacement. Okay. Then if d square theta upon dt square be the acceleration of the bob towards O, and L be its moment of inertia, I be its moment of inertia about the point of suspension, and is perpendicular to the plane of paper, the moment of force. The torque acting on the bob is also given by tau equal to I into alpha, that is I d square theta upon dt square, Okay, therefore I d square theta upon dt square equal to minus mgl sin theta, okay, because tau equal to minus mgl sin theta. Okay, then d square theta upon dt square equal to minus mgl upon I into theta, since moment of inertia of the bob about the point of suspension is ml square. Okay, then since d square we have d square theta upon dt square equal to minus mgl into theta whole upon I equal to ml square. I equal to ml square because I equal to ml square because the bob about the point of suspension, the moment of inertia of the bob about the point of suspension is ml square. Point of suspension is ml square. Okay, that is m is cancelled out by m, and 1l is cancelled out by 1l. Then minus g upon l into theta, that is minus mu into theta. Okay, where d square theta upon dt square equal to minus mu theta. Okay, where mu equal to g upon l. The acceleration per unit displacement. The acceleration per unit displacement. Acceleration per unit displacement. That is d square theta upon dt square into alpha minus theta. Thus the angular acceleration of the bob. The angular acceleration of the bob is directly proportional to alpha is directly proportional to its angular displacement. Okay, its angular displacement, and is directed towards its mean position, because this is negative sign. Okay, hence the pendulum executes simple harmonic motion, and its time period will be t equal to 2 pi under root of 1 upon angular acceleration per unit angular displacement. Okay, that is t equal to 2 pi under root of 1 upon mu. That is t equal to 2 pi under root L by G. Okay, from the equation first gives of the simple pendulum. Okay, this gives a period of the simple pendulum. Okay, next is compound pendulum. Next is example of simple harmonic oscillator. What is the example of simple